Okay, section 4.4 is on permutations when objects are identical. So when we basically have repeats. This is my third attempt at recording this lesson because the first time I didn't turn my mic, second time didn't save, third time, hopefully the charm. So we're looking at the same stuff that we've done in the last section with permutations, except this time we're going to do it when we have a repeat of either letters or a repeat of factors. So let's use the sock analogy again, and let's say we have 4 pairs of socks, but this time 2 of our pairs repeat. So let's say we've got 2 pairs of red, a blue, and a green. That's going to limit your permutations that you can make as to how you can wear those socks, or what day of the week you can pick to wear those socks, because you have a repeat in there. So you'll remember, those of you who are in Pre-Calc 30, we did something similar with this with the alphabet, just to see how repeating a letter affected how many permutations you could have. So this one says the permutations of 4 different letters, A, B, E, and F, are as listed below. So how many permutations are there in total? There are 4 factorial, or 24. So remember, 4 factorial is the same as 4 times 3 times 2 times 1. So we've taken, and in our first spot we have 4 choices of putting in there. Once we've put that in there, the second spot we've only got 3 choices of letters. Once we've used that one, then there's only 2 choices, and then there's 1 choice. So what happens if 2 of the letters are the same? So investigate this by converting each F to an E in the list below. Then count the number of permutations we have. So if every single F on here turns into an E, like so, what happens to the letters? So if we look now, we have A, B, E, E here, A, B, E, F, or A, E, B, E, A, E, B, E. So we can kind of divide them up like so. Okay, so 2 side-by-sides are the exact same permutation. So what we've done basically is we have reduced our number. We've gone from 24 down to 12 permutations. So how does this compare with step 1? Well, it's half as many. Because 24 divided by 2 leaves us with 12. So basically what we've done is we've taken our 4 times our 3 times our 2 times our 1 and divided it by 2. So what happens then if 3 of our letters are repeating? So we're going to change our F and E's to B's in each of these. So these all become B's. Oops, some of these are getting a little crazy. Okay, so I've turned all of my F and E's into B. So if we look down here, we've got an A at the beginning, and then the rest of the row is B's. We've got a B in the beginning, A second spot, and then B's. Our A in this row is in the 3rd spot, and then the A in this one is, of course, in the last spot. So how many permutations do we have now? We have 4 distinct permutations. How does this number compare to step 1, where we've gone from 24 to 4? So we have 1/6 as many, because 24 divided by 6 leaves us with 4. So that's like saying our 4 times 3 times 2 times 1 that we originally had is divided by 3 and 2. And you could say times 1 if you wanted to, because that's just going to give you 6 anyway. So it says, given the pattern from the investigation, generalize the pattern from the investigation to determine the number of permutations of A, B, C, D, D. So what we notice up here, if we look at this example, our permutations on the top were the total permutations we could get. There was 4 letters, so we did the factorial of that. So that means for this one we have 1, 2, 3, 4, 5 letters, so it'll be 5 factorial. And then on the bottom, since this was the same as 4 factorial, and this is the same as 3 factorial, that 3 factorial relates to how many repeated letters we have, or how many times that letter repeats. So in this one, our A was once, or B was once, or C was once, but our D repeated twice. So that would equal 60. Our B, A, B, D, D, D. So we've got 5 letters again, so that's going to be 5 factorial. We have 1 A, 1 B, but 3 Ds. So that's kind of like the one up there, except we have the 1 extra letter on top. So 5 factorial divided by 3 factorial is just 20. So what about if we have 5 letters and 4 of them repeat? So we're going to do 5 factorial divided by 4 factorial, which is just 5 permutations. Now this one has a repeat of 2 letters. So we'll start with our 5 factorial, but we have to take our repeat letters out. So since that one repeated twice, we'll take it out twice. That one repeated twice, so it's going to reduce those permutations by those. So this leaves us with 30 possible permutations. For this one, we've got 5 letters, but we have the A repeating 3 times and the B repeating twice. So that equals 10. So our generalization says the number of permutations of n objects where A are identical, another B are identical, and another C are identical, and so on, is the number that we have factorial over the product of the repeats. So let's try some examples. Determine the number of permutations of all the letters in the following words: statistician and Canada. So if I take a look at this, my S, I have 1, 2 S's. Oops. For T's, I have 1, 2, 3 T's. A's, there are 1, 2 A's. I, 1, 2, 3. I only have 1 C, and an N is 1. Better make that. I like that. So altogether, I had 12 letters, so I'd have 12 factorial ways of arranging them. And then I take a look at my repeats. Well, I had a 2, I had a 3, a 2, and a 3. I could include my 1 and my 1, but 1 factorial is just 1, so it's not necessary. So this is the same as, 12 factorial over 144. So that's 3,326,400. Remember, you can do these on your calculator by using that math and PRB function. Oh, I'm going to sneeze. All right, Canada. So Canada, we have 1 C, A's repeat 3 times, and nothing else repeats. So in total, we have 1, 2, 3, 4, 5, 6 letters, and that A is repeating 3 times. So that is 120 possible permutations. Number 2. How many ways can the words of Canada be arranged if the first letter must be N and the last letter must be C? So they're putting some stipulations on what you're doing here, and once you have those kinds of restrictions on there, that's going to limit how many arrangements you have. So this, first of all, this box here should be there. So if we take a look at this one, it says our first letter must be N, so we've got rid of that letter, and our last letter must be a C. So we've got rid of 2 of the letters that are there. So then that means we are left with the rest of the letters, and it doesn't matter which order we put them in. It just matters that we actually put them in there. So using our NPR function, we know that that is n factorial over n minus r factorial. So if we do this, we've got 1, 2, 3, 4 letters. And we're arranging them one at a time. So what I'm looking for is for this spot here. Whoops, I should have done this. So I've got 4 letters, and I'm choosing them one at a time. So that's the same as 4 factorial over 4 minus 1 factorial, which is 4 factorial over 3 factorial. So if I use my NPR, then I get my 4 factorial over 3 factorial, which just also works out if I just did a regular, the general formula for this one, I would have 4 choices of letters, but 3 of my letters are repeating. So what I would do is I would multiply my number of letters together then, or number of total arrangements together to find out what my total amount is. So this one, I have 1 choice for here. This was my 4P1 choices, and this was my 1 choice here. So I have 1 times 4P1 times 1, or 1 times 1 is just 1, so it's just that 4P1. So 4 factorial over 3 factorial leaves me with 1. Okay, solving some routes. If you're trying to go from point A to point B, there's a lot of different ways you can get there. So we're going to look at some examples of these. So Julie's home is 3 blocks north and 5 blocks west of her school. How many routes can Julie take from home to school if she always travels either south or east? So basically she's not backtracking. So in the textbook on this page there's three people's suggestions. So for the first suggestion was if she went all the way south, so she went this way and then she went east. So what she's done is gone south, 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 and then east, 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 till she got to her destination. Okay, another option is if she went 3 blocks east, 2 blocks south, 1 block east, 1 block south, and then another block east. So she's gone east, 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 south, south, east, south, and then finally east. The third option that was suggested is send her east and then send her south. So she's gone east, 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 and east. Whoops, that's a bad E. And then she's gone south. So no matter what, she has to go, and you could go on forever doing this. Well, not forever, but you could go on for a long time. No matter what, she's gone a total of 1, 2, 3, 4, 5, 6, 7, 8, because it's 8 blocks. Regardless of which way she goes, it's always going to be 8 blocks to get there. So all of her options, and we've only listed 3, are going to be permutations of 8 letters. We're always going to have 5 E's and 3 S's. So the number of routes she has then is going to be 8 factorial, because that's her total number of possible permutations over those repeats. So 5 factorial over 3 factorial. Which equals 56. So she's got 56 different ways that she could go to get there. Method number 2 is using a diagram. Oh, and I lost my textbook. In your textbook, on page 264, it shows you a second way, which is kind of looking at a pattern that you're using. So if you went, she goes 1 block this way, or she could go 1 block this way. So in total, she has traveled, so these are all 1, 1, 1. She's going 1 block always in that direction. 1, 1, 1. So that means to get to this distance here, she would have to travel 2 blocks. To get to this distance, then, she would have had to go on 1 over, 1, 2 down. So she'd have to go 3 blocks. If she wanted to get to this spot here, she would have to go 2 over, 1 down. So she would have had to travel 3 blocks. If she wanted to get to this spot here, she would have had to have gone in some way, shape, or form 1, 2, 3 blocks this way, 1 block that way, so she would have to travel 4 blocks. This spot here, she would have to go 1, 2, 3, 1, 2, 3, 4. Why is that one not adding up? Oh, sorry. She would have done her 3 blocks or her 3 blocks for a total of 6. So what this is doing, and it's starting to get a little confusing the way I'm explaining it there, but if we see, look, we have a pattern. We have this, if I add this value here and this value here, it equaled that value. If I add this value and this value, the 1 and my 2, it gives me a 3. If I add my 2 and my 1, so my corner values above are always going to equal the value that they would join together to make. I'm just going to change my pen color. So this value right here has to be the total of the 2 values that join together to meet it. So this means 4 and 6 would leave me with 10. I need to finish my triangle this way. So this value here would be a value of my 3 and my 1, so it's a 4. This value here is the corners of the other one, so 4 and 1 is a 5. This value here would be 5 and 1, so it's a 6. To get to here would be 6 and 4 is 10. This spot here is 10 and 10, so it's 20. This spot here would be my 10 and my 5, so 15. This spot here is my 20 and my 15, so 35. And then finally, over in here, my 15 and my 6 will give me this spot of 21, and my final dot here, 35 and 21, gives me my 56. So if you look at this, this has followed a specific pattern. And this pattern, and those of you who were in pre-calc last year will remember Pascal's theorem. Or Pascal's triangle, I guess. And we use that for the binomial theorem. So we start at the top with 1. Our next row is has to have 2 numbers, so it's a 1 and 1. The next row has to have 3 numbers, so we always carry that 1, and then it's adding. 1 and 1 is 2, carry down the 1. Next row, carry the 1 there. 1 and 2 is 3, 2 and 1 is 3, carry down the 1. So my 5th row needs to have 5 numbers, so my 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, carry a 1. Carry a 1, I've got 5, 10, 10, 5, 1, carry 1, 6, what's that, 5 and 10 is 15, 20, 15, 6, 1, and that gives me my 1, 2, 3. My pattern to fill in my values here. So, because remember, across here would be a 1, and down here would be 1. So, if I look at this row here, I have my, where did it go? 1, 6, 15, 20, and then I would repeat here going 15, 6, 1. Okay? So that's what this pattern is following. So by doing that, I can get to my rows by using that one. And if you add that up, 1, 6, 15, 6, 20, and 1, if I said those right, that'll give you your values that you need. Using a diagram method takes a lot more, because you have to, first of all, recognize that you can use the pattern of Pascal's triangle to get you your answer, but also just to figure out your values is going to take you longer. So wherever you can use the permutations, then you do. So, in summary here, there are fewer permutations when some of the objects in the set are identical compared to when they are all different. The number of permutations of n objects where a are identical, another b are identical, another c is n factorial over a factorial times b factorial times c factorial, and so on. And then something that you need to know, dividing n factorial by a, b, and c factorial, and so on, deals with the effect of repetition caused by objects in the sets that are identical. It eliminates arrangements that are the same and that would otherwise be counted twice. So kind of like when we add sets together, we take away that middle part when we have sets that have something in common, otherwise we add them in there twice. So your assignment there is page 266 to 269. Have fun.